Hello everyone, welcome back to Tutor's live class. So we have started with the brand new chapter that is nothing but matter in our surroundings. So today's session is in continuation with the same chapter. Before moving ahead, let's quickly recap whatever we have covered in the session 1. So we have covered topics such as what? First topic was definition of matter. Okay, then we have learned about the chemical or composition of matter. Then the third topic was classification of matter, and the last one was characteristics of particles. Also we covered about physical classification of matter. We know that like matter is classified into two categories, and based on the physical properties we have seen what physical classification of matter is. Okay, and it was based on the states. So we have covered state number 1, that is solid. Are you able to recall, like we covered some properties which are related to solid, like internal arrangement of the particles and the force of attraction which these particles are experiencing. Okay, so like diffusion, sublimation, these were some properties which we have seen so far. Now what are we going to learn in today's topic? What do you think? Of course, the next state, and the next state is nothing but what? Liquid. So we are going to understand what is the chemical structure or arrangement of particles in liquids, followed by the third state, that is what? Gases or gaseous state. Now the fourth state, that is plasma, and fifth, which is BEC. So in today's session we are going to cover these topics. So are you all ready? Let's get started. So this is nothing but state number 2 of matter, which is liquid state, right? Give me some examples of liquid. Water, juice, ink, oil, right? These are few examples of liquid where we see matter is present in the state liquid. Now we have seen the internal arrangement of particles in case of solid. So here also we are going to learn about how these particles are arranged when we talk about liquid state. So here is the first thing, like the arrangement is based on the interparticle force of are less in comparison solid state and more than gaseous. So we need to understand how these particles are arranged internally. Okay, once the arrangement is done, we have learned about the force of attraction. This was the very first term which we learned. Apart from that, like is there any distance among this particle? Did we observe this in solid? No, they were very compact. These particles were very close to each other. But here in liquids this won't be the case. Let's see how it is. Suppose I have taken a beaker and we are having some liquid molecules. Consider this is nothing but a water, example of water system. Okay, so it will look like this. How it is different from solid state? If we'll see closely, there are some spaces between these molecules, between these particles. Okay, so these are some spaces. That means these particles are staying away from each other and definitely not like solid particles. Okay, and I told you, if you all remember, when we are studying about the force of attraction and spaces, how these two terms are related to each other. Like less space, can you tell me? Less, if there is less space between these particles, what happens? Like what is the thing? Like more force of attraction. Less space is nothing but what? When we are having like less spaces among these particles, they are experiencing less or more. What do you have to say? Exactly. Less spaces are dealing to, or they are going to give you the more force of attraction, which we saw in case of liquid. More space of, just a minute, let me remove this out. Okay, so here is the liquid. Okay, these are liquid particles. Okay, these are the spaces, And what was the relativity here? If spaces are less among these molecules, that means more is the force of attraction, FOA, force of attraction. Okay, less space, more force of attraction. Vice versa, when we are having more space, then I can say less force of attraction. So here we can observe that the spaces here are quite more among these particles of liquids. So more space, less force of attraction, or interstitial force of attraction is quite less when we compare it with solid particles. Followed? So that's what we have written here, that interparticle forces are less in comparison solid state than gaseous state. So basically whenever we study about these states, we are going to compare it with solids, liquids, gaseous particles. Okay. Interstitial space is quite larger than solids, but it is less than gaseous state. Okay, so these spaces are larger than solids but less than gaseous state. All right. Moving ahead. Yeah, here are some examples such as oil, milk, water, juice. These are few examples where we usually see matter in the form of liquid. Okay, and the interspecial spaces are more. If I want to draw, so when we are comparing it with solid particles, these particles have more spaces than solids and less force of attraction than solids. Okay. So here is an activity. I just want you all to look here. That suppose we are having container A, container B, container C, container D. Okay, these are 4 containers we are provided with. Now we are pouring some liquids in it. Okay, it's very clear that the shape of these all containers look very different from each other. And when we are pouring some liquids, be it any chemical, can you all see like it has already taken the shape of that container, right? So different container with different shapes, and that's how our liquid is having different shape. Okay, so what can we conclude out of this? Liquids do not have any fixed shape, but volume wise, yes, it's 300 ml. Okay, it's I can say 400 ml. It's 40 centimeters. So what we can say that the volume is fixed, but the shape is not fixed when we talk about liquid molecules. So let's understand this characteristic one by one. So shape and volume. Shape is not fixed, whereas volume is fixed. When we talk about the next property, that is really very important, such as density. Now, as we have studied in solid particles, they are very close to each other, and that's how they are quite dense. But here, in case of liquid, the particles are moving like they are having some spaces among them, and that's how the density is quite less when we are comparing it with solid particles. Because they are not rigid, liquids are not rigid. Okay, because of this interstitial spaces or force of attraction, right? Now the next property is what? Compressibility, ability to compress. What do you think, which particle will be more compressible, solid or liquid? Yeah, you're right, you're typing it very correct, liquids. Okay, so ability to compress is higher when we compare between solid and liquid, and definitely it's quite highest among these 3 when we talk about gaseous particle, which we are going to cover soon. Now talking about fluidity, it's nothing but what? Ability to flow. Ability to flow. So liquids have this tendency to flow, and that's how we say water flowing, honey flowing or oil flowing. These are the all liquids which have this tendency to be able to flow basically. It is because of again their structural arrangement. They are not very compact, they are not, the particles are not very closely attached with each other, and that's how we have seen solids are rigid and they cannot flow, whereas liquids they can flow. Okay, Mechanical strength, definitely the ability to withstand any burden or load is maximum when we learn about solid particles, and again it was because the arrangement of particles. Here comparatively it's low. Okay, when we are going to compare it with solids, definitely mechanical strength of liquids is quite negligible, right? Moving ahead, we have the next property, that is diffusion, ability to mix with each other. Liquids, yes, we have observed this property when we are comparing it with solids. So liquids diffuse with each other very nicely than solid particles. Then we are having next property such as boiling point. So on comparison, boiling points are quite low with if we are comparing it to solid particles. Same goes like freezing, okay. And then we are having what the next property is, what? Evaporation. So it is nothing but a phenomena where there are some liquids that tend to get transform themselves from liquid state to gaseous state, okay, without any further external supply of heat energy, or without they do not have to achieve their boiling point. It's a natural phenomena which is observed in case of liquid state. We are going to study about evaporation in detail in our further classes, like what is evaporation and how it's differing from boiling point, etc. Okay. So let's move ahead and let's recall whatever the properties of liquid particles which we have learned so far. So interparticle attractive forces are very less, or they weak. Okay. Interstitial space is large, and that's why the force of attraction is quite less or weak, right? Particles can freely move. Yes, this was something which was absent when we studied about solid particles. Being very rigid or compact, they do not have tendency to move very fastly. They are able to vibrate on the position where they are located. But here, liquid particles can move, little movement is there, okay. Collision of gas particles on the walls of containers results in gas pressure. Okay, this is something, a property which we are going to learn in gases. But here, what I want to explain, consider this is a container which has some liquid molecules, and as I told you, these liquids can move. Okay, they can move from here to there to here, like very random, very haphazard manner. Now imagine when they are moving from this place to this. Okay, let's suppose this is what is your wall of any container. Okay, this is nothing but a wall. When they are moving from one place to the wall of container, basically they are exerting pressure, and this pressure is higher in terms of gaseous particles. Okay, and that pressure is nothing but gas pressure, or in liquid we can say liquid pressure, though it's less in liquid state, but it's quite higher when we study about the gas particles, which we are going to cover soon. So now here is the thing, okay, what you all can see here, there are so many pretty balloons, right? So point here is that a balloon seller fill the balloon with gas from cylinder. How does this happen? Like how the change in the shape of that balloon happened? Because the balloon seller has filled some air in it, right? So we know that when we say air is nothing but what? A mixture. Do you all agree with this? Is it a mixture? It is. Which one? Homogeneous, right? And what it comprises of? Different types of gases and what? Water molecule or moisture. And when this mixture is getting observed, we have seen that it is quite homogeneous, okay. Like we are not able to see nitrogen molecule different, or oxygen molecule, or the water molecule, no. And that's how we say it's uniformly spread, distributed, and that's how we say here is a homogeneous mixture of gases, right? So here we need to understand the third state, which is what? Gaseous state. But before that, do you all know like how many gases are present in the environment? Do you all know the number, specific number? Okay, if you know, please do type in the chat box so that I can read, I can go through the answers. Yes, yes. So in the periodic table, we see 11 gases are there. Okay, and in today's session, we are going to cover the general properties of gases. So far, we have covered solids and liquids and their properties. Now it's time to understand about gaseous state. So here is the thing, like it's an activity basically. What we are going to do, like take 300 ml syringes and close their nozzles by rubber cork. Okay, this is nothing but a syringe. Okay, what you have to take, like you have to take 3 syringes. Okay, and now remove the pistons from all the syringes. Okay, now leaving one syringe untouched, fill water in the second. Okay, so you are supposed to take 3 syringes, one has nothing inside it, like do not need to fill anything inside it, but it has what? Naturally it is consist of air in it, though we say it has nothing, but it has air in it. And second, we need to fill it with water, and third with some pieces of chalk. Okay, now what is the idea here? What is an activity? I want you all to press the nozzle and try to compress these 3 syringes. What do you observe? Among these syringes, which one, like for to get compressed, you are going to put extra amount of energy? Air, water or chalk powder? Which one? What are your observation? So yes. So we say that like when we are going to compress, or actually the purpose of this activity is to study the compressibility. Now to compress the chalk powder, you are going to need like the highest amount of energy is needed when we compress the pieces of chalk, right? And comparatively less in case of what? Water. And we don't have to supply any extra amount of energy to compress the air which is there in the first syringe, right? So hence proved like solids are like we need more amount of energy to compress them, then less amount of energy to compress liquid particles, and gases are very easy to compress. Got it? All right. So here is the we need to compare among these 3 states of matter very quickly with respect to all the properties or the characteristics which we have studied so far. So let's understand them one by one. So we are having solid, liquid and the third state gas. So first property, interparticle space. So interparticle space is very small in case of solids. Okay, it's like larger when we talk about liquids, and it's the largest among gas particles, correct? Second is interparticle force of attraction. Now the spaces are very small, the force of attraction is very high. Okay, so that's how we say it's very strong in case of solids. It's moderate or it's quite weaker when we study liquid particles, and it's quite negligible in gaseous particles. Have a look, these are the structural arrangement or particles in solid state, liquid state and gaseous state. Observe, there are no spaces, okay, and there are some spaces among these particles, and see in case of gaseous particles they are way away from each other when we are comparing among them. Moving ahead, we need to understand what is the trend in density. It's high in solid state, it's quite low in liquid, and it's very low in gaseous state. Okay. Next is arrangement of the particles. Now we know that in solids the arrangement of particle is quite regular, and that's how we can say it's fixed when we say when we study solid particles. No fixed particles can move freely within the bulk. Okay, so now the fixed part, like in case of liquids, particles, they do not have their fixed position, right? And that's why they can move here and there, correct? Now in case of gaseous particles, they're away from each other, and now they can move like randomly from a place to the other. Okay. Energy of the particles. So energy of the particles in solids, it's quite low. It's high in liquids. It's very high in gaseous. Now next is shape and volume. We have seen that solids have definite shape and volume too. But in case of what? Liquids, no definite shape, but it has a definite volume. Moving ahead, gaseous particles, they do not have any definite shape or any fixed volume. Now the next property is what? Diffusion, ability to intermix two or more substances into each other. Solids, definitely it's quite negligible, but it's comparatively higher than solids when we study about liquid particles, and it's very high in gaseous particles. Okay. So alright, these were some properties of solid, liquids and gases. Is there any confusion? Is there any problem? Have you all able to follow till here with me? So far we have done with 3 states of matter. Okay, let's move ahead. Now after studying about these 3 states of matter, have you all familiar with the 4th state, which is plasma? Yeah. But many people think that there is no 4th state, but it is. That's nothing but plasma. So what plasma is exactly? Definitely it is the 4th state of matter. The particles are highly activated and convert into charged particles. Okay, we'll just go through it first and then I'll try to make it very easier for you all. So coexistence of charged particles and electron is considered as plasma. Okay, and where do we get to see this state? It's like 90% of matter in the universe is found in the 4th state, which is what? Plasma. Okay, so let's understand what does this mean. Consider that we are provided with solid particles, okay, and we know that the arrangement of solid is like this, very compact, very closely packed. And if you are going to apply some external heat to this, okay, let's suppose that you have applied some heat, what is going to happen? What is your observation? What we have studied so far? Yes, now these particles are going to absorb some energy and they are going to transform themselves into liquids. Okay, these particles are going to get away from each other, and that's how the shift is going to happen. Consider now this liquid is getting heated. We are going to supply some amount of heat to this liquids also. So from solid to liquid. What do you think, what will be happening next? Can you guess about it? Yes, again these particles are going to get absorbed, the extra amount of it which we are supplying, and now from liquid the shift is happening to gaseous particle. All right, from solid to liquid to gas. Okay, so we have supplied enough amount of heat. Now till here everything looks fine. Okay, now whatever I am going to say after this, try to understand. Basically we are talking about the next state. Consider now we have supplied the heavier range of temperature is there, like we are supplying so much heat to the system. Okay, this gaseous particle are getting heated, be it like 1000 degrees Celsius, 3400, such a huge range. Okay, so we are continuously going to heat the substance or heat the gaseous particle, right? So what will be the result? What do you think? What will happen here? We have reached till the gaseous state. What after that? Actually, what happens, let me tell you, like before understanding like what is the next step, let me tell you something. Focus here please, students. Actually, there is this very important topic such as atomic structure, okay, and it talks about the structural arrangement of an atom. It talks about like atom is comprises of subatomic particles such as electron, proton and neutron, okay, and where do they locate in an atom? So let me draw it something like this, okay. Now in this is what is your nucleus. The central part of an atom is what? Nucleus. And we are having shells. After the nucleus, like it is surrounded by various shells. So, point here is that in the nucleus, we get to see the presence of proton and neutron. Okay, this subatomic particles stay in the central part of an atom, that is nucleus. And here we need to understand shells are having what? Electrons. And number of protons, number of neutrons, number of electrons differ as we change the matter or as we change the element or the atom. Okay. So point is here, nucleus is consist of protons and neutrons, okay, and shells are consist of electrons. Okay. So actually I have drawn an atom from here. Let's suppose this is a gaseous atom, and what is going to happen to this to that atom here? Suppose if we are going to supply some amount of heat with the higher range of temperature, okay, with the high range of temperature. So what is going to happen, you know, there will be a point where the whole system will get heat up, okay. So it will like the atom itself is going to reach at a stage where electrons are going to jump out, electrons are going to knock out. They are coming out of their shell, the outermost shell. Okay, following? When we are heating up the substance or an atom, there will be a stage, okay, that electrons are going to get outside from their outermost shell because the higher range of temperature which we are supplying to the system. Okay, and here is the thing, we have studied about the ions. Okay, when electrons is getting loosed by the system, okay, we know that we get electron is getting accepted by the system or in the outermost shell. When there is an acceptance of an electron, two things happen. On losing of electron, we get what? Anion, right? Losing of electron gives anion, is it? Purposely I am doing this so that I just want to check the attention in the class. When a substance or any atom is going to lose an atom, we are having cation. There is a formation of this ion which is cation. And when an electron or atom is going to accept an electron, that is nothing but your anion, which is negative in charge, okay, and cation positive in charge. So class, be attentive, do not just sit there and see and be interactive. Correct your teachers like if they are doing it purposely. So do not follow, pay your attention. Cation positively charged, anion negatively charged. Alright. So here what is going to happen now when electrons are jumping out? I told you when electrons are getting out of the system, we are going to get charge, which is what? Cation, right? So atom, what happens when we heat gaseous state? We get, there is the formation of two things. Let's suppose this is an atom, okay, they are getting heat up. Because of that, electrons are going to jump out from the system and we are having electrons, we are having free electrons, Okay, so within this we observe that we are having positively charged particles of the same atom which is surrounded by freely available electrons which have knocked out from that atomic structure because of the heat which we have supplied. And now we are able to see the system is having like a cation particle and negatively charged electron. So when this happen in the gaseous state which is quite heated up, it is nothing but it gives the next step, that is what? Plasma. And that's how you must have read it here. The particles are highly activated and convert into charged particles. So basically these are the charged particles, cation particle and electrons, which are nothing but like negatively charged particles basically. Okay, so gaseous vapors are getting heat up, and because of that electrons are getting knocked out, and now they are ionized. Whatever is the remaining part, okay, this is nothing but I can say ionized particle, ionized gaseous particle which are electrically charged. Okay, so here coexistence of charged particles and electron is considered as plasma. Coexistence. So this charged particle and electron which has jumped out or knocked out from the outermost shell, they are staying together. That's why the word is coexistence. So this coexistence of charged particles and electrons like togetherly, we are labeling the state as plasma. Followed? Are you able to understand this? So that is what is the fourth state of matter, that is plasma. Solid to liquid to gas. Now we are going to heat gaseous particle at such a great level that electrons are going to get knocked out themselves from the outermost shell of an atom. Okay, and we are having what? Coexistence of this ionized part and electrons. That is what is plasma. Okay, so are you all able to understand whatever we have covered so far? Is there any confusion? Okay, so we are learning plasma for the first time. Okay, so make sure that you all are able to follow it here. Okay, quickly make note of this. If you need some time, you can take it. Done? Okay, moving ahead. So where do we get to see this fourth state? You must be wondering, ma'am, right now in the class itself we are able to see chair, table, fan, etc. These are all the things which are in solid state. So majorly we say on the earth the solid state is the common state, most common state of matter, but it is not the fact. Actually, if you'll see, as I told you earlier, 99.9% our universe is made up of plasma. Okay, so majorly we observe this state in the universe, in the stars. Composition of star is nothing but it is made up of plasma. Okay, so here space and astrophysics plasma, that is what in case of sun, stars, solar. So these are the areas or the substances which are made up of plasma. Again, here we have observed like existence of plasma in the lightning. Okay, when lightning happen, it is happening because of the plasma. Okay, then we have artificially produced plasma. You must have seen some neon lights or fluorescent light lamps. Okay, something like this. Okay, so these are some neon lights. It is because we are we being human, like because of the technology, we have modified it and we have artificially created this plasma and we have started using in the lights. Okay, so these are some areas where we see application of plasma or the existence of plasma, which is the fourth state. Okay. Moving ahead, we are having the next state, that is what? Fifth state of matter, which is Bose-Einstein condensate. Bose-Einstein condensate. You must be wondering, ma'am, it looks like a big name, like how it can be a state. So it has a history behind it. We need to be very, very proud of, because very first time there was this physicist in Kolkata, okay, Satyendranath Bose or SN Bose. So he observed, he studied about this state BEC very first time. Okay, so he tried to publish his article, but it didn't happen. So he wrote a letter to the great Sir Einstein. Okay, and now Einstein has observed his theory or thesis or the observation, like how Satyendranath Bose has correctly said about the fifth state which can exist. And he supported his theory also, because he was also studying the same thing. And eventually it got published, and now it is in front of us, like that's how the name is Bose-Einstein condensate, which is BEC. So now what this is all about? So in plasma, we have seen that plasma is nothing but ionized gaseous particles, which are, we are going to heat them up and we are going to ionize them. It's a positively ionized part which is surrounded by electrons which are knocked out or which are coming out from the atom of gaseous particle, right? Here we are going to understand something in reverse of that. So basically BEC is totally opposite of plasma. So here what we can do, what we are going to see is that we are going to cool down the substance almost towards the absolute zero, which we can't even imagine. Like it's, if you'll see, it's a physical Bose-Einstein condensate is opposite to the plasma. That's what I told you just now. And it can be observed at absolute zero temperature. Okay, it is such a low temperature where we are observing the existence of this state, which is BEC. So atoms are at lowest energy state at absolute temperature. In case of plasma, the atoms, because we supplied huge amount of heat, okay, now the atoms are quite heat up. Now they tend to lose their electron. But here the case is completely reverse. We are going to let them cool, and cooling results in the losing of energy, right? So energy is the lowest. See, we are going to cool them down at absolute zero. So what happens that there is aggregation of these atoms at such a low temperature, and this results in the structure something like this. Okay, there is accumulation of the particles which are having low energy, because we are cooling them down at absolute zero temperature. And that is what is the fifth state which being observed as, or which being recognized as BEC, Bose-Einstein condensate. Got it? So here we need to cool down the substance or the atoms at such a low temperature, okay, and because of that they are going to get condensate. Because of that they are going to get aggregated and gonna form a cluster of molecule, or going to give the fifth state, that is what BEC. So yes, that was today's session. Now it's time to revise whatever we have studied with the help of some questions. So I'm going to show you some questions, and I would like some answers to hear from you all. Okay, let's get started. Which of the following statements is incorrect for state of matter? Your options are: A, the force of attraction between the gas particles is very less; B, plasma consists of super energetic and super excited particles; C, the plasma glows with a special color depending on the nature of the gas; D, Bose-Einstein condensate is formed by heating gas of extremely low density. we need to find out the option which is incorrect. Think over it and just let me know about your answer. Okay. I can see your answers. Many of you are replying in the chat box. Good. So let's understand this. So they have asked to choose a statement which is incorrect. The force of attraction between the gas particles is very less. Yes, we know that these particles are staying away from each other, and that's how they are, the force of attraction is quite like it is almost negligible or very less. Plasma consists of super energetic and super excited particles. That's what I told you, like when gaseous atoms are getting heated up at such a higher range of temperature, they are getting extra charged. That's how the word which is we are using here is super energetic and super excited particles. So this statement is correct. The plasma glows with a special color depending on the nature of the gas, and this is what is the property of plasma. And the fluorescent lamps, this is where we use this property of plasma. That is also correct. Option C is also correct. So we are left with option number D, that is Bose-Einstein condensate is formed by heating a gas of extremely low density. Just now we have covered BEC. Did we heat the gas? No. We cool it down at the absolute temperature, right? So this has to be your answer. Option D. Got it? Which of the following is not a property of gas? So here we need to understand or revise the property of gas. A. Gases have a definite shape. B. Gases have neither definite volume. C. The rate of diffusion of gas is higher. Option D. Gaseous particles are in a state of random motion. Which of the following is not property of gas? It's very simple, right? Yes, keep typing. I can see. It's a very simple question for you all. I do understand this. Absolutely, the answer is A. Gases have definite shape, and this is what we do not study so far, like they do not have any further shape, right? They take the shape of the container. Gases have neither definite volume. Yes, they do not have any fixed volume. The rate of diffusion is gas in it's higher, or is the highest among these three states of matter. And gaseous particles are in a state of random motion. Yes, they are moving from here and there. It's a haphazard way to move. That is what is the movement which we have observed in gas particles. So this is what is the not a property of gaseous particle, right? Moving ahead, a form of matter has no fixed shape, but it has a fixed volume. An example of this form of matter is what? Like these are the examples. Option A is carbon dioxide, B ice, C water vapor, D is kerosene. So what you all have to say on this? A form of matter has, okay, I would like to help you here. Form of matter has no fixed shape, but it has a fixed volume. What should be your answer here? Okay, let's discuss. Carbon dioxide, it's a gas, right? Ice, it is like if we want to talk about the state, it's solid in state. Water vapor, again, it's in gaseous state. But kerosene, it's what is in liquid state. Now apply the properties of liquids or gaseous states here. A form of matter has no fixed shape. So among these, who has no fixed shape? Definitely liquid, right? But it has a fixed volume. So among gaseous particles, like if I want to compare between gaseous and liquids, liquids has no fixed shape, but it has a definite volume. That's how your answer has to be option number D. Got it? All right. So yeah, this is what today's session was. So let's summarize whatever we have learned so far. So we have studied about the physical classification of matter, in which we covered all the steps or states of matter such as liquids, gases, plasma and Bose-Einstein condensate. Okay, so just I hope you all have taken some notes. Go through them, revise the topics which we have covered so far, and I will be going to come up with the next session where we are going to discuss these other concepts of the same chapter. Till then, bye, take care.